Hello, space explorers! Today we are going to dive into the fascinating world of computer simulation theory. Forget everything you know about reality, because we will consider the possibility that each of us is just a character in a big space video game. What is reality, and do we have the means to define it? Let's consider all our senses: sight, sound, touch, as electrical impulses perceived by our brain. Perhaps we are all just sleeping, and our life is an incredible dream. Is there a chance that our universe is just a computer simulation? Dozens of scientists are searching for evidence or refutation of this incredible hypothesis. It is clear that our distant descendants will have virtually unlimited computing resources and will be able to create virtual worlds similar to ours. Given the likely large number of such worlds, the chances remain slim that we are lucky enough to live in the real world, and not a simulation. Could it be that the entire universe, with its infinite size, with all the nebula, stars, planets, could be a simulation? Previously, only philosophers were interested in such questions. Scientists were trying to understand what our world is and explain its laws. But recent discoveries about the structure of the universe still raise existential questions for science. Dozens of scientists are trying to find proof or refutation of the simulation hypothesis. Speaking of this extremely intriguing hypothesis, it should be noted that it is not only based on the imagination of individuals, but is beginning to be supported by a number of scientific studies and experiments. The top of the mysterious ice is the most famous experiment, the interference pattern paradox, in which elementary particles begin to behave differently based only on the fact of the presence of an observer or measurement. The result of this experiment is the conclusion that the presence of an observer or measurement destroys the wave function of elementary particles. How can this happen in the real physical world? Or does it all look more like a simulation program running on some overpowered computer that simply lacks either the power or the need to constantly monitor the physics behavior of elementary particles? And it does so according to a simplified model in the form of probability waves, and more precise calculations begin to be made only when specific particles are observed, and their physics changes at the same moment so as not to disturb the illusion of the reality of the world. And now there is a strange but deep impression, as if imprinted by the realization that nature knows not only when we observe it, but also when we plan to do so. But if the world behaves depending on whether we are looking at it or not, what would reality really mean? And here is an analogy to hear, enjoy, and reflect on. A tree fell on a distant desert island. Would you hear the sound of it falling or not? After all, sound is air vibrations that are transmitted to our senses and perception. But can we say that an event has occurred if there is no one who can hear it? A question that leads us deeper into the realm of quantum mysteries and reality. We open the next chapter in our research, which reminds us that our reality may be just an impression in a huge virtual game. Why are speed and time so closely related in our universe? And why is there a maximum speed that cannot be surpassed? Thanks to Einstein, we all know that nothing can move faster than photons in a vacuum. The speed of light is a constant. The fact is, friends, that our world is organized in such a strange way that the faster an object moves, the more its time slows down. And this has been proven by numerous experimental experiments. When the speed of light reaches the following value, time stops altogether. Simply put, if you had a spaceship capable of accelerating to the speed of light and decided to use it to go anywhere in the universe, that is, for example, 3 billion light years away, you would get there in an instant, because during the flight, time would completely stop for you on your spaceship, and at that moment, 3 billion years would have passed on Earth. So photons are moving at a speed close to 300,000 kilometers per second, and it is simply impossible for them to accelerate even faster, because to increase the speed, it is necessary to slow down the time, which for them is already at zero. So why does the universe work this way? Why does speed cause time to slow down? It's a question that leaves us amazed and curious. Or perhaps the answer lies in the very idea of a virtual world. Perhaps the limited speed of light in a vacuum is the result of maximum information processing in this simulation. Maybe the virtual world is only updated at a certain finite rate. The world's most powerful computer has already achieved a performance of 1.1 exaflops. For your understanding, I want to say that 1 exaflop performance means that a machine can perform a quintillion, or a billion operations per second, a number with 18 zeros. And what will computers be capable of in about 100 years? Simulation within simulation? Interesting. Taking all this into account, we can assume that our generated universe could be calculated quintillions of times faster, but the principles remain mostly the same, and the time slows down with increasing speed because virtual reality depends on virtual time, where each processing cycle is one tick of the clock. It's also incredible. After all, there is also quantum entanglement, which in turn violates the laws of the real physical world even more, proving that information between pairs of bound elementary particles can be transmitted instantaneously without any delay, exceeding the speed of light billions of times. And again, this is inextricably linked to the observer effect, and in the case of simulation can be perceived as a simple bug. Today, some physicists believe that quantum theory can explain how our brains work, because if quantum objects can be in two places at the same time and instantly transmit information to each other, then maybe our brains, which also use quantum effects in their work, can function in a similar way. And there are more and more questions. Dear friends, let's imagine people of the future modeling different scenarios of historical development or simulations, and these will not be modern simplified models, taking into account the enormous computational capabilities that they will have in the future. They may have at their disposal very detailed simulations, in which everything and every geographical detail will be independent and visible, and every animal and every person. And each of these individuals will be endowed with the same level of computing power and complexity of intelligence as a living person. They can be created on the basis of software, but at the same time, they will have the mental characteristics of a human being. Of course, they may never realize that they are a program to live, to love, to enjoy, to develop. And maybe after a while, they will create another simulation in their own world, which will be no different from their real world. And the question is, how many such simulations can there be in each author, and where to find the way out to reality? What world could all this have started from? All this is, of course, extremely intriguing and interesting, but not proven. That is why it continues to be called the hypothesis of computer modeling of the universe. Thank you for watching, dear friends. It was a very exciting research and discussion of the computer simulation hypothesis. We look forward to your comments. It is interesting to know your thoughts and experiences on this topic. Don't forget to subscribe to our channel, because we have many more interesting and exciting things to share with you. See you on our space journey.